A warm greetings from Rohini College of Engineering and Technology video lecture series. I am Professor Radhika from Chemistry Department. In this video, we discuss about a new topic, phase rule. After completion of this phase rule topic, students can be able to explain the basic definitions and terms in a phase diagram. Let us see the introduction of phase rule. So we know that the chemical reactions can be classified into two types. One is irreversible reaction and reversible reactions. So we know that this reversible reactions are once again classified into two types: homogeneous reversible reaction and heterogeneous reversible reactions. The homogeneous reversible reactions can be studied using the law of mass action, but the study of heterogeneous reaction or heterogeneous systems require different methods. The phase rule is given by Willett Gibbs in the year of 1874, which is used to study the behavior of heterogeneous reversible reactions. Let us see the basic and more important definitions of phase rule. Phase rule. So in an equilibrium which is exists between any number of phases is not influenced by gravity or electrical and magnetic forces, but it is mainly influenced by pressure, temperature and concentration. Therefore, the number of degree of freedom of the system is related to number of components and number of phases. By using the phase rule equation, F is equal to C minus P plus 2. So this is called as a phase rule. So the equilibrium exists between any phase, any number of phase, which is mainly influenced by pressure, temperature and concentration only. Therefore, the phase rule is given by F is equal to C minus P plus 2. Here F indicates degree of freedom, C means component, P means pressure. Let us see the definition of phase. Phase is defined by, before that we have to discuss the merits of phase rule. Phase rule is applicable both in physical chemical equilibria. It is a convenient method of classifying the equilibrium states in terms of phases, components and degree of freedom. It helps to decide whether the given number of substance remains in equilibrium or not. Similarly, this phase rule also possesses some limitations. It can be applied only for systems in equilibrium. The three variables like pressure, temperature or concentration considered, but not electrical, magnetic and gravitational forces. Let us see phase. Phase is defined as any homogeneous, physically distinct and mechanically separable portion of the system which is separated from other parts of the system by a definite boundary. The best example is gaseous phase. Okay, so we know that the gases are exist in the mixture. Air is a mixture of all kinds of gases, particularly oxygen, nitrogen, hydrogen, carbon monoxide, carbon dioxide and water vapor. It constitute only single phase. So we can't separate physically but mechanically separable portion of a system. So it is denoted as phase. Similarly, let us consider one liquid phase, benzene water system. Here the two liquids are immiscible, so it forms three phases. One is that is one vapor phase and two liquid phase. One benzene phase, one water phase and another one is a vapor phase. So the number of liquid phase depends on the number of liquids present and their miscibilities. Let us consider alcohol water system. So here both liquids are completely miscible, so it forms one liquid phase and one vapor phase alone. Let us consider the decomposition of calcium carbonate. Calcium carbonate undergo decomposition, it produces calcium carbonate and carbon dioxide. It consists of three phases: solid calcium carbonate, solid calcium oxide and gaseous carbon dioxide. Then we move to component. Component is defined as the smallest number of independent variable constituents by means of which the composition of each phase can be expressed in terms of chemical equations. We know that the water system can express in three phases, like in liquid phase, solid phase, as well as the gaseous phase. Even though it exists in three phases, in all the three phases, the component is expressed by a single chemical equation, that is H2O. Therefore, its component is only one. Similarly, consider the sulfur system. Sulfur exists in four phases, that is rhombic, monoclinic, liquid and vapor. Even though it exists in four phases, its chemical composition is only one, that is sulfur. So it belongs to one component system. Then we move to degree of freedom. Degree of freedom is defined as the minimum number of independent variable factors such as temperature, pressure and concentration, which must be fixed to define the system completely. In order to define the system properly, we need the parameters like temperature and pressure. Therefore, the degree of freedom is very important in phase rule. Okay, let us consider the water system. In this water system, all the three phases are in a equilibrium only at a particular temperature and pressure. Therefore, this system does not have any degree of freedom, so it is called as a zero variant or non-variant. So, with the help of these definitions, we draw the phase diagram. Phase diagram is nothing but it is a graph obtained by plotting one degree of freedom against another degree of freedom. Normally, the phase diagrams are classified into two categories. One is pressure temperature diagram as well as temperature concentration diagram. These phase diagrams are mainly used to predict the phase diagrams whether an eutectic alloy or a solid solution is formed on cooling, which containing a mixture of two metals. It is mainly used to understand the properties of materials in the heterogeneous equilibrium system. The study of low melting eutectic alloys used in soldering can be carried out using phase diagrams. Okay students, thank you for listening. In the next video, we will discuss about one component system. Thank you.